So the next question, A4, page 95. Textbook, let me read that on page 95. If a square plus b square x square plus 2 into sc plus bd into x plus c square plus d square equal to 0 has no real roots, then we have to find the right choice there. Given to you is a square plus b square into x square plus 2 into sc plus bd into x plus c square plus d square is equal to 0. So we have this. Okay, let me check once more. Yes, this is the one. So here we have x squared term, x term, and the remaining having no x square x, the third term. Okay, so here we have to first find out a, which is the coefficient of x square in front is a square plus b square. Just listen carefully. Then comma b is the coefficient of x in front of x up to here. So 2 into sc plus bd. Then the c value is here c square plus d square. Remaining part is the c. So question go back. They have no real roots. So no real roots means this one not real. This condition we're going to have to use. So we can write here since the given equation has no real roots according to the question. The exact language of the question, no real roots. So no real roots means not real, this one. The condition for which is this. So you can write here therefore b square minus 4sc. There are only three conditions, right? Real and equal roots, real and distinct roots, and roots not real, right? So b square minus 4sc not equal, sorry, less than 0. So be careful with that. Follow me closely. So that implies here b here, as you can see, twice into sc plus bd. This is b, but b square means you have to put a second bracket because the whole thing is squared. So b, this one, square, so square outside, minus 4 into a is this one, a square plus b square into c. So c is here, c square plus the square 4 into a, as you can see, into c, as you can see. So that one, b square minus 4c is continue with the same sign, less than 0. So now we can write here, that implies 2 square is 4. So I just write the 4 into here, sc plus bd, sc plus bd, and here square belongs to 2 to the 4 there, and this also. So the square has to go there now. This square belongs to both this sc plus bd whole square as well as 2 square, which we have already written 4. So here minus 4 into a square plus b square into c square plus d square less than 0. So follow that closely. Then here I can see common factor, so let us remove 4 and 4. So let's take that out of the bracket. Since we have used first bracket, let's put a second bracket. Then here sc plus bd whole square, only 4 taken out, so this will be there inside. 4 taken out, so plus into minus, the matching minus, then 4 outside, so only this portion left, so inside the bracket a square plus b square and bracket c square plus d square, bracket close. And for to compensate this second bracket right here, since the second bracket starts here, it ends there. So 4 is been taken out, and then this one is left inside. 4 is taken out, and these two portions same inside. I hope you're getting it right. Then here, that gives you here, let me go slow, step by step, going a little bit longer. So here, if you can see here, that implies, let us say this portion, forget about the 4 for some time, ac plus bd whole square minus, same thing you write, a square plus b square, a square plus b square close bracket into c square plus d square is less than 0. So less than 0, so that one you can show here, less than 0 divided by, we're shifting this 4 into, if you shift to the right side of this less than sign, it will go to denominator, so 0 by 4. So we can continue. I think we don't need this space, so I can just write here. From here I'm coming here. So now let us deal with these two parts here. Okay, if you want you can continue with this bracket. A plus b whole square, let us imagine that. So a square, a plus b whole square. Formula is a square plus b square plus 2ab, the common formula, and I apply that. So a is AC, b is bd. So a square, AC whole square, plus b square is this one, bd whole square, plus 2, because this is a plus b, so into a is this AC, into b is this bd. So a square plus b square plus 2ab, this for this one, so minus the bracket. Then here you can see here minus then bracket. Let's multiply this. This portion is done, a plus b whole square, then minus here. Now here we have written already minus, so don't bother about this minus now. No, this will multiply both of these. After that this will multiply both of these. So let us start with a square. A square into c square is a square c square. Then this minus is already written, don't look at that, done. Then here plus, so plus into plus is plus a square into d square, so plus a square d square. This multiplying this, then go, this is multiplied both, so now go here, plus into plus, plus, then b square into c square, b square c square, then plus into plus, plus, then b square into d square, b square d square. So this is bracket closed. So here this has multiplied these two, this has multiplied these two, and we got these 4 terms, so that this portion is multiplying these two factors, this into this. Then here less than 0. Then let me go to the next step. So that implies here we can see here I can now write, I can remove the bracket heading, a square c square plus b square d square. The square will belong to both, the square will belong to both, plus here 2 into a into c into b into d, b into d, a c b d, a c b d. Then here minus into plus is minus a square c square, minus into plus is minus a square d square, because this minus will multiply everything inside, then only this bracket will remove. Okay, so here also put one more thing, this bracket close here and then second bracket. Okay, then when you multiply this minus to all these 4 terms, then this first bracket will get removed, and even the second also we don't need anymore, so I've removed it. This done, then minus and plus is minus b square c square, then minus and plus is minus b square d square, and less than 0. Keep on going carefully. So here plus a square c square and minus a square c square, same 0. Plus 2 minus 2 is 0, similar to that. Plus b square d square minus b square d square, 0. Plus b square d square minus b square d square, 0. Then we're left with this. So let me just take out here, listen carefully to this. I want to rearrange this as 2ab. So let us take this a. Let's take out minus, this minus out of the bracket. Then minus, I'm not starting here, I'm starting this 2. Okay, if you can start here also, but I want to start with this minus out. So minus and plus is minus a square d square, minus and the plus is minus again b square c square. This is gone, now these 2 done. Now come here, only term left, the rest are all 0, see, done, gone. So here this one plus 2acbd, acbd. So this minus has been taken out, minus into plus, minus a squared d squared, minus into plus, minus b squared c squared, minus into plus, sorry, this is minus into minus, because this is plus, minus into minus, then only plus, so minus into minus, plus 2acbd, minus into minus, plus, matching now. Then here, less than 0. Then here. You can do like this. Next, I don't like to put minus here. If I want to change, you can change. For example, now here, change this minus to plus, then a squared d squared plus b squared c squared, same thing, minus 2acbd. Everything is same except that minus is removed. Then this side 0 means, actually minus removed means this plus then become minus, but 0 is neither plus or minus, so we keep it same. Now see here, since I removed the minus, changing sign, so this sign here will change to smaller than, will have to go ulta, greater than. I've explained previously also, but once more. For example, minus 4 is, let us say minus 4 is minus this number. Let us say minus 4 is smaller than 0. So that is correct, because let me take some time to explain, because these are important. On the integer scale line, 0 is middle, right side is bigger than 0, plus 1, plus 2 is bigger than plus 1, plus 3 is bigger than plus 2, 1 and 0. So like that it goes positive numbers. But negative integers, minus 1 is smaller than 0, minus 2 is smaller than minus 1 and minus 0. Minus 2 is smaller than minus 1 and minus 2 is smaller than minus 1 and 0. Minus 3 is still smaller than minus 2. So negative ones, bigger values are smaller, bigger absolute values are smaller, right? So here, minus 4 is smaller than 0, because on the left of 0 are smaller than 0. So if you put one more if you want, minus 4 is smaller than 0. That's correct. But suppose you change the sign here, then this sign will remain same, because 0 has no sign. Then if you don't change, then this is, by common sense also we understand this is wrong, right? Plus 4 can never be less than 0, so this is wrong. So if you change this sign to plus, this also will change, but 0 is not sign, so it remains same. Then we have to change this, then only it's correct. That's why we're changing this sign smaller to bigger. Just like you're changing minus to plus, then smaller to bigger. I hope you got it. Right, so once we're through with that, that gives you here. Now look here, this looks like let's take this as A. So AD, both of them same power, so AD whole thing square. This square belongs to A, so A square, D square. Then this square, you can put in common, B, C common, and put square common power. Let us take this as A, so A square plus this one B, so BC is B, BC square, A square plus B square, minus 2 into, don't look at this, just look at this, A we have decided to take, AD, B we have decided to take, BC. Then try to match whether it's same with this or not. A, D here, B here, C is the same. You're just rearranging A and D together, B and C together to match up with this A square plus B square minus now 2 into A into B greater than 0. So that way we can get here now formula A square plus B square minus 2AB is A, this one is A, minus B, BC, the whole thing square. We know the formula, right? A square plus B square minus 2AB is equal to A minus B whole square. So we're using this formula. A minus B whole square. This portion greater than 0. So as we proceed, we're going to get here. So here, if you remove the square, then AD minus BC square removed, then it will come here greater than plus minus root over 0. So that implies AD minus BC greater than plus minus 0, but 0 is neither plus nor 0, neither plus nor minus, so we don't put any sign. So that way you're going to get here AD, and you shift this minus BC right side, comes greater than BC, AD greater than BC. So AD is not equal to BC. So the right choice that matches this answer, once you've written that, is go to textbook question. The choices here. First one, AD equal to BC. That's not correct, not matching our answer here. This is our answer. Then AD equal to CD. None of them are equal. SC equal to BD. There's no equal, greater than sign. So last one is the correct one. AD not equal to BC, because AD is greater than BC, so it's not equal. So the fourth choice, number 4, where AD is not equal to BC, is the correct choice, because in actuality AD is greater than BC, therefore they are not equal, is the correct choice. 2 more questions, 5 and 6. A5. Let's go to A5. If the roots of 5x squared minus kx plus 1 equal to 0 are real and distinct, then, so we have to find that. So given here is 5x squared minus kx plus 1 equal to 0. So here, very clearly we can see coefficient of x squared, which is denoted as a, is plus 5, coefficient of x, which is minus k, and c equal to the third term plus 1. Since, according to the question, let's look into your text, the given equation, meaning this equation, the given equation, the roots of the given equation, okay, same language we can use there, like the textbook question, roots of the given equation are real and distinct, are real and distinct. Therefore, real and distinct is this one, see, real and distinct. So this condition we have to use. B squared minus 4AC greater than 0. And then find your k, I think. Yes. So here, let's go about it slowly. B is here, as you can see, minus k, so put it in a bracket, square b square minus 4 into a, here you can see 5, c is 1, same sign, greater than 0. So minus k square means minus k into minus k, so minus into minus, plus k into k square, so plus k square means we don't need to put plus, understood, plus k square minus 4 5s are 20, greater than 0. That gives you k square. If you shift this minus 20 right side, become same sign, because we are not changing sign but side. Minus 20 goes right side, plus 20. So here, here's this square. Now I want to explain this part. So we're going to have to write, therefore, either, therefore either, if you remove square, then root is coming right, root over 20, root over plus 20, k will be same sign when you remove square, or because its root one value is negative, that's why the other should be k, then this greater will change to ulta, lesser than, positive will be same but negative will be ulta, and then minus root over 20. I'll explain it. Okay, let me go 2 more steps and explain it. So that gives you k will be greater than, now 20 is prime factorization, 2 10s are 20, 2 5s are 10, so 2 into 2 into 5 we can write, root over 2 into 2 into 5, or k is less than root over 2 into 2 into 5 minus, sorry, less than minus. So k will be greater than, this 2 will come out as single 2 plus 2 root 5, no partner, so inside, or k less than minus, this 2 will come out as single root over 5. Now why we kept this same, because k is greater than plus 2 root 5, then definitely suppose k is 3 root 5, then you know that 3 root 5 is plus 3 root 5 is greater than, I'm explaining, you don't need to write, okay, it's greater than 2 root 5. Everybody will agree. Just like 3x is greater than 2x. Consider root 5, the common literal factor as x. So 3 mangoes is more than 2 mangoes. 3 root 5 more than, greater than 2 root 5. That's correct for positive. So we didn't change. But since same value here but negative 2 root 5 here plus 2 root 5 minus 2 root 5, then it's a totally different story. So if we do that, we don't change this and keep really this and write minus 2. Okay, so here k is, we're supposing that it is 3 root 5 is k. So if we write negative, okay, then here see 3 root 5 minus 3 root 5, suppose the negative answer, and we don't change sign, greater than minus 2 root 5 will be wrong, because negative numbers, bigger value minus 3 is smaller than minus 2, not greater. So that's why we needed to change this ulta to this greater than and smaller than. So 3 mangoes, 3 root 5 less than 2 mangoes. That's why we needed to put, reverse the greater than sign to smaller than sign for the negative value of the same absolute value. Absolute value is same. Absolute value means value without the sign consideration. So plus root 5, absolute value is 2 root 5, minus 2 root 5 also 2 root 5. So both of them have same absolute value, but the sign is different, plus and minus. For same absolute value, positive one will be having same sign, then the negative will be, suppose positive is greater, then negative will be smaller. With this explanation, I hope you got it, right? Now, one more question before we complete. So this is your answer, k greater than 2 root 5 or k less than, either k greater than plus 2 root 5 or k less than minus 2 root 5. And the answer that matches this is the fourth one. So textbook choice, fourth one, this is our answer. K greater than, either, it's given as either k greater than plus 2 root 5 or k smaller than minus 2 root 5 is the right answer. I hope you got it right. Now next, A6. A6 is here. A6. Find the value of k for which the quadratic equation has real and equal roots. So we have here 16x squared, 16x squared plus 4k into x plus 9 is equal to 0. So here we can easily take out a means the coefficient of x squared, which is plus 16, b means the coefficient of x, which is plus 4k, c is the third term here, plus 9. And we have to find k. So since question is saying, look into your question, since the given equation has real and equal roots, comma, real and equal, this condition we have to use therefore. So therefore we're going to have to use b squared minus 4ac equal to 0 because they have real and equal roots. With that we'll find out k values. B is here, 4k, whole thing, bracket is a mass square, minus 4 into a is 16 into c is 9 is equal to 0. So I'll go about it slowly. 4 4s are 16 and k squared, so we write here k squared because this power 2 belongs to both of these. Then minus into plus minus, minus into plus minus. So 4 into 16, 4 6 are 24. 4 1s are 4 5 6. So 4 into 16 is 64 multiplied with 9 should be our answer for this portion. 9 4s are 36, 3 in hand. 6 are 54, 55, 56, 57. So 576. 576 is equal to 0. So next, 16k square is equal to shift this to right side plus 576. As we go about it, continuing, then we're going to get here. That implies k square will be equal to 576 divided by this 16 into will go down to denominator. So 4 is going, I think 4 4s are 16, 4 1s are 4, 1 in hand. That will go in front of 7, so 17, 4 4s are 16, plus 1 16, plus 1 17, then the remainder 1 will go to the left side of this 6. 16, 4 4s are 16, 4 1s are 4, 3s are 12, but 14 is there, so 13, 14, 2 remain there, 24, 4 6 are 24. The way k square is removed, then equal to plus minus root over 36, because we remove square, so plus minus root will come on the other side. So there will be plus minus 6 6 are 36, so single 6. So k value is 6 or minus 6. So our answer choice that match this is the third one is matching our answer. So 6 or minus 6. So that is the S6 completed for this test part. Okay, I hope you understood.